Hello, Algebra 2, 7.5, Solving Rational Equations. Just want to say I'm really proud of you. You made it. Last one, keep finishing strong, do the right thing, do it the right way, and you'll have some good tools to move forward in your life. So, looking forward to seeing you next year. Maybe around this summer a little bit. That'd be great for me to see you again, but not for sure next year at some point, except for two of you, I guess, but maybe see you online. So, solving rational equations. These are all rational equations, okay? Because you have a rational expression and an equal sign. That makes it an equation. We're just going to pretty much jump right in here. And the first set of it here is you're going to solve it by cross multiplying when you have two rational expressions equal to each other. So you just have two parts. Compare that to later on when we see we have three parts and things are being added and subtracted. Okay, we'll have to treat those a little bit differently. But if you have two parts, all you need to do is cross multiply. So I'm going to take this whole expression up there, that whole expression up there. So I get 2 times 2x minus 7 equals 5 times x plus 8. 4x minus 14 equals 5x plus 40. And so x equals 54. Okay? And now you check that. Is this number in the domain? So remember, these rational expressions are defined everywhere except for where the denominator equals 0. So if you do this work and you get an answer like x equals negative 8, that would be an extraneous root. You'd have to throw that out and you'd say no solution. So if you get a number that is not in the domain, you're going to throw those numbers out. So in this case, yes, it is in the domain because it doesn't make that equal 0, so that would be your solution. Okay, number 2, cross multiply. So I get x times x equals negative 4 times x plus 1. There's your x squared equals negative 4x minus 4. You have a quadratic term, so bring everything to the left side. X squared plus 4x plus 4 equals 0. And now we have to factor it. What multiplies 4 adds to 4, and that'd be x plus 2. So x plus 2 squared equals 0 because it's x plus 2 times x plus 2. So we get x equals negative 2 as our solution because that's when this equals 0. Negative 2 plus 2 equals 0. Go up, check it. Okay, it's everything except negative 1 and 0 for our domain, so this is okay. Cross multiply. So x plus 1 times x minus 6 equals x plus 2 times x minus 3. And here you get to double distribute or do the FOIL process. So x times x minus 6 plus 1 times x minus 6. So x squared minus 6x plus 1x minus 6. And we get x squared minus 5x minus 6. This other side, we're going to get cozy on this, aren't we? We get x times x minus 3 plus 2 times x minus 3. So we get x squared minus 3x plus 2x minus 6. So that's x squared minus x minus 6. Okay. Now when we solve this, the x squareds cancel off because it's 1x squared and 1x squared, so they both cancel off. I'm going to add the 5x over here and add the 6 here. I get 0 equals 4x. So x equals 0. All that, and we get x equals 0. So check that. That's a big one. We look up here, we're like, okay, 0 should work, because 0 minus 3 is not 0, and 0 minus 6 is not 0. So anything, if we would have gotten a 3 or a 6, we would have had to throw those numbers out and either have no solution or our answer would be the remaining numbers. Okay, next one, negative 2 times x plus 21 equals x plus 9 times x minus 3. So negative 2x minus 42 equals x squared plus 6x minus 27. Do the double distribute. So get this all on one side. So I need to add the 2x, I need to add the 42. So 0 equals x squared plus 8x plus 15, I believe. 15. 42 minus 27. Yep, that's 15. So factor that, x equals, 0 equals x plus 5 times x plus 3. That look right? 3 times 5 is 15. 5 plus 3 is 8. So I get x equals -5 and -3. So let's check that up here. 3 would not work. We'd have to throw out a 3 and -21. So -5 and -3 should be okay. Okay, so if you have two parts, get them on different sides of the equal sign and then cross multiply it. Now we get into the three parts. Solve the equation by using an LCD. LCD is least common denominator. Least common denominator. Okay, that'll be a little bit new for some of you. What we're looking at here is you're looking at the denominators and you're like, okay, I have a 7 and I have an x. The LCD is going to be the highest power of every factor in the denominator, the bottom part. The highest power of every factor in the denominator. So when we have a 7 and an x, 7 is a factor and x is a factor. The highest power of 7 we have here is 7 to the first power. The highest power of x is x to the first power. So our LCD here, and it's not a liquid crystal display either, is 7x. So what we're going to do is I'm going to put parentheses around this whole thing. And this 5 is going to get in my way. But I'm going to take that common denominator and I'm going to put it over 1 and distribute it to every part. Now I want this to go faster. I'm going to take every single step here right now and simplify each one. Okay, so 7x over 1 times 4 over 7. 7x times 4 is 28x over 1 times 7 is 7. Okay, so here we go. 7x over 1 minus, so we have a minus sign, 1 over x. So 7x times 1 is 7x. 1 times x is x. And don't forget the equal sign. And 7x over 1 times 6 over 1 would be 42x. So we're going to multiply all by this common denominator. And notice what happens with each of these. I still have these denominators, like why did we do that? But 28 over 7 becomes 4. So we get on the top, if you do this correctly, your denominators should cancel off. And this is a trick you can use to always get rid of your denominators. So 4x minus 7x over 7 is going to be 7, and that equals 42x. All of a sudden we have a linear function and we can solve this. So minus the 4x, we get -7 equals 38x. So x would be -7/38. What a weird number. 4x minus 7. 6 times 7 is 42, right? Okay, that's where we're going to go with that. We're going to go with that. You can always plug that in, make sure it doesn't conflict with this. No, that's good. Okay. 0. If we got a 0, you'd have to throw it out because that's not in your domain. It actually does work. I was checking in my head there for a little bit. Okay, so this one, binomials, x plus 1, x plus 2, x plus 2. These two are the same factor. Okay? These two are the same factor. The highest power is just 1. So in this case, our least common denominator is going to be one factor of x plus 1. Since we're so tight in here on space, we're going to... So x plus 1 is one of our common denominators, and I have x plus 2, it shows up twice, but my highest power is just 1. So our common denominator is x plus 1 times x plus 2. Okay, so you're basically taking part of everything that you can down here. So when I distribute this to here, what I'm going to end up with is this is going to go to every single top. Okay, so everything on the top goes to every single top. So 3 x plus 1 over x plus 2 over x plus 1. Notice what's common, we're going to cancel that off. Plus 4 x plus 1, x plus 2 over x plus 2. Okay, this canceling off stuff is something you can do in your head as you're working this out as well. And that equals 15 x plus 1, x plus 2 over x plus 2. Okay, and this is what we're going for here, getting the denominators out of there. So I get 3 times x plus 2 equals 4 times x plus 1, not equals, sorry, plus 4 times x plus 1 equals 15 times x plus 1. Okay, so 3x plus 6 plus 4x plus 4 equals 15x plus 15. So that would be 7x plus 10 equals 15x plus 15. So negative 5 equals 8x. So x would equal negative 5/8. Domain is everything but negative 1 and negative 2, so we're okay. X equals negative 5/8. Yeehaw! Are we having fun yet? Okay, it's on the back side. Ooh, we got lots of practice. Okay, we can practice this lots and lots and lots. Down here, I see that I can factor this. So I want to factor this. This is x times x plus 4. And you notice there's an x there, and there's an x plus 4 there. So my common denominator is going to be x times x plus 4 over 1. So when I take it times the first one, I get 12x times x plus 4 over x plus 4. The part that's common will be canceling off, leaving us with 12x. Minus 7x times x plus 4 over x. Here the x's cancel off, so I get minus 7 times x plus 4. That minus the 7 in parentheses are important. The minus in the parentheses, you have to distribute in negative 7. And this is going to equal 22x times x plus 4 over x times x plus 4. Both parts cancel off, so it's just going to equal 22. So 12x minus 7x minus 28 equals 22. So 5x equals, oops, that should not be 28x. There you go. So 12x minus 7x is 5x. Add the 28 over, it equals 50. So x equals 10, which does fit in our domain. So x equals 10. Okay, this one I have an x minus 1 and an x, so I'm taking everything. That's 3 over 1 if it helps, times x minus 1. So here I have 3x times x minus 1 over 1 minus 18x times x minus 1 over x minus 1. You see how I didn't have to write the x minus 1s because they're going to cancel off. And it equals a negative, I'm going to put the negative on top, negative 12x times x minus 1 over x. You see here I didn't have to write the x because that's going to cancel off. So I get 3x squared minus 3x minus 18x equals negative 12x plus 12 because you're distributing the negative 12 to the negative 1. So get it all on the same side, 3x squared, 3x minus, that's negative 15x plus 12 would be negative 3x, and then minus 12 equals 0, factor out a 3, so x squared minus x minus 4 equals 0. Ooh, boy, did we do this right? 3x squared, I'm going to double check this real quick. Minus 18x, yes, equals negative 12x plus 12. Alright, so it looks like we do have a quadratic that is not factorable. 3 minus 18, oh that is, hang on, here we go. Negative 3 minus 18, negative 21. Negative 21 plus 12 is negative 9, which makes this a negative 3. Ooh, that's better. So that'd be x minus 4 times x plus 1 equals 0 when you factor it using ma. So x can be 4 or negative 1. Check our domains. 1 and 0 would not work, so both of those should work. Okay? You can always plug them in and check them, make sure they fit with that. Okay, let's see if we can speed this up a little bit. So factor this, x times x minus 5. I'm going to take everything times x and x minus 5 over 1. So when I do this first one, the x minus 5s will cancel, I get 2x. Plus, when I do the second one, the x's cancel, giving me 3 times x minus 5. And do a third one, they both cancel off, leaving me with 10. So 2x plus 3x is 5x minus 15 equals 10. So 5x equals 25, so x equals 5. Now, we plug that in here, and we get a 0. So this is an excluded value, and this will have no solution. We don't have any other options there. No solution on that. Okay, factor this bottom one. I'm going to guess it's going to be x minus 4 and x minus 1. And what multiplies to positive 4 adds to negative 5. That would be x minus 4 and x minus 1, the two numbers we have there. So that's going to be our common denominator, x minus 4 times x minus 1, times each of these three parts. So when I take it times this first one, the x minus 4's will cancel off, leaving me with x plus 6 times x minus 1. Okay, the x minus 4's are gone. When I look at the second part, there's a minus sign and there's a 30. And you notice it has both parts and both parts. They both cancel off, so all I'm left with is the minus 30. Here it's 3. The x minus 1's will cancel off, giving me x minus 4. So x squared plus 5x minus 6 minus 30 equals 3x minus 12. So that would be x squared minus a 3x over plus 2x. I got negative 36 plus 12 would be negative 24. So this factors into x plus 6 and x minus 4. So here I get my answers as x equals negative 6 and 4. Okay, negative 6 and 4, but check, we cannot use 4. 4 is an excluded value. Negative 6 would work, so I'm going to throw that one out. I'm just going to use that one. Okay. Those are called extraneous roots. Extraneous roots. Okay, extraneous roots. Okay, factor x minus 5 times x plus 2, which is the same. So I'm going to take everything times those, x minus 5 times x plus 2. When I take it times this first expression, x minus 5's cancel off, leaving me with x times x plus 2. Plus, there's a 2 in the next one. X plus 2's cancel, so I have x minus 5. And then here 11, you have both parts, it just equals 11. So I get x squared plus 2x plus 2x minus 10 equals 11. So x squared plus 4x minus the 11 minus 21 equals 0. So I factor that, I get x plus 7 times x minus 3 equals 0. So I get x equals negative 7 and positive 3, which both fit in my domain. So I'd have two answers on that one. So these first three examples, we've had a no solution. We've had two solutions where we had to throw one out. And now we have two full solutions. See what this last one brings us. So this factors into the same thing, the parts that we have here. X minus 4, it's always good to check that, x minus 1. So x minus 4 times x minus 1, that's our common denominator. I take it times this first part. They have the x minus 4's out cancel, so I'm left with x minus 2 times x minus 1. That's the first part. Minus, there's a 2 there. The x minus 1's would cancel, so I'd have x minus 4. And it equals 12 because both parts would cancel there. So I get x squared minus 3x plus 2 equals negative 2x plus 8 equals, minus 2x plus 8 equals 12. So x squared minus 5x, okay, 2 plus 8 is 10. 10 minus 12 would be a minus 2. Okay, hang on. That's not going to factor pretty. X squared minus 3x may have to use a quadratic formula. So negative 2x plus 8 equals 12. That should be okay. So x squared minus 2x minus 1x, which is minus 3x minus 2x, yes. Okay, quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4ac. So minus 4 times 1 times negative 2. So that'd be plus 8. all over 2a, all over 2. So x equals 5 plus or minus the square root of 33 all over 2. So those would be your two answers. 5 plus square root of 33 all over 2, and 5 minus square root of 33 all over 2. Okay, now that's what your assignment's going to be over. A few extra things. Determine whether the inverse of f is a function. If you remember the horizontal line test, that's where you get to use this. So you can graph it and then find out that the inverse is a function. Define the inverse. Remember when y equals 8 over x minus 3. Switch them. So x equals 8 over y minus 3. Now you have to solve for y. So I'm going to take this whole thing and move it over here. So x times y minus 3 equals 8. So xy minus 3x equals 8. So xy equals 8 plus 3x. Divide everything by x, and you get y equals 8 plus 3x over x. So we end back up here, f inverse of x would be 8 over x plus 3 if we're going to simplify it. That's kind of weird. Kind of the same numbers there, but mixed around like that. That is coincidence. It doesn't always work like that. Okay, so xy, this would be x minus 9 equals 12 over y. So y is going to equal 12 over x minus 9. So f inverse of here of x would be 12 over x minus 9 if you go through all the steps. Okay, this last one is non-review, Mr. Sattler. Since you had those other questions for me, you can complete yard work at your friend's home in 5 hours. Working together, you and your friend can complete the yard work in 3 hours. It's a little bit different approach than I did on the papers I sent to you, Mr. Sattler. How long would it take your friend to complete the yard work when working alone? Okay, let T be the time in hours your friend would take to complete the yard work when working alone. So you can do 1 yard in 5 hours. So you can do 1/5 of a yard. But together you're working for 3 hours. Okay, so if I multiply these, so how I like to think of it is I can do 1 yard in 5 hours. So in an hour, I can do 1/5 of the yard. Now my friend, he can do 1 yard in t hours. We don't know that. So he can do 1/10 of a root in a yard. And together, we can do 1 yard in 3 hours. Okay? So me, friend, together. We're doing 1 yard in 5 hours, 1 yard in t hours, 1 yard in 3 hours. Common denominator there would be 15t over 1. So when I take it times the first one, the 5's cancel off, leaving me with 3t. Take it times the second one, the t's cancel off, leaving me with 15. Take it times the last one, the 3's cancel off, leaving me with 5t. So 15 would equal 2t, and t would equal 7.5. So it would take your friend 7.5 hours to do that job alone. Okay, so that wraps it up. If you want to practice some more of these 15, those are things that can come up later on. I have a sheet, compliments of Mrs. Sattler, that you can get lots of practice with that if you want that. I can send that to you, or she can as well. So let me know what questions you have. Congratulations. Very proud of you, and looking forward to being able to teach in person again soon. Talk to you later. Bye.